Hello everyone. So in this presentation we will discuss what metal finishing is, and then we will also discuss how electroplating of chromium is carried out. Metal finishing is nothing but it is a process of coating a metal on the surface of another metal to modify its surface properties. As we all know about paint finishing is nothing but applying paint on the surface of a metal. Similarly, metal finishing is also done. Metal finishing is nothing but coating of one metal on the surface of another metal. To modify the surface properties of the base metal, another metal layer will be coated. Say for example, iron, it has strength but it is not attractive. To make it attractive, so what we are doing is we are coating it with a layer of another metal. Gold is very attractive, but we cannot use gold in all the purposes because of it is highly expensive. So to meet all the desired properties, we are doing metal finishing. So to get the desired surface properties, one metal layer will be coated on the surface of another metal layer. So that process we call it as metal finishing. Metal finishing is carried out by two methods. One is by electroplating, another one is by electroless plating. Electroplating is nothing but a process of depositing a metal on the surface of another metal by electrolysis process. So here electric current will be used, and with the help of this electric current, electrolysis takes place, and then a metal layer will be deposited on the surface of another metal. Whereas in the case of electroless plating, it is a process of depositing a metal on the surface of another metal by using a suitable reducing agent without using electric current. So whatever the electric current is playing role in the case of electroplating, here a redox reaction will be playing that role. So in order to understand how electroplating process is carried out, it is very important to know the theory of electroplating. What is the principle behind electroplating process? That is very important. In electroplating, we will be having one electroplating tank. This electroplating tank contains plating bath solution. It contains anode and cathode. Okay. Pure metal will be the anode. Pure metal in the sense the metal which you want to deposit on the surface of the substrate, that will be made as anode, and cathode will be made up of the substrate or the article on which you are going to deposit a metal, that will be the cathode. And plating bath solution contains the salt solution of the metal to be deposited. Say for example, if you are depositing zinc on the surface of the substrate, then the pure zinc will be made as anode, and any zinc solution, say for example zinc nitrate, zinc chloride, zinc sulfate, etc., should be present in the plating bath solution. In addition to this metal salt solution, some other additives will also be present in the plating bath solution, like some organic compounds will be present, some complexing agents will be present. They have their different roles to play to make sure that the deposition will be taking place better. So what actually happens here? When you apply the electric current, the pure metal, I have shown in the reaction, the pure metal M, it undergoes dissolution to form respective metal ions. And in the plating bath solution, I have represented the metallic salt solution as MX. This salt will undergo electrolysis to form respective metal ions and other ions. So now in the plating bath solution, the metal has undergone dissolution to form the metal ion, and metal ion from the salt, it has undergone electrolysis. Now both the metal ions are present in the plating bath solution. Now under the influence of voltage, these metal ions, they move towards the cathodic surface, that is towards the surface of the substrate, wherein they undergo reduction and they get deposited over the surface of the substrate. And after obtaining a desired thickness, we need to stop the electroplating process, take out the substrate, and now this substrate will be having a layer of pure metal on its surface. Now to take it out and use it for various application purposes. This is how electroplating process will be carried out. Now we will see how electroplating of chromium is carried out. So in chromium plating, we have two different types: decorative chromium plating and hard chromium plating. Decorative chromium plating, as the name indicates, it is used to make the surface look attractive. Hard chromium plating used for the industrial applications. So in the case of decorative chromium plating, on the surface of the substrate, nickel undercoat will be given, and then on that nickel undercoating, a very thin chromium layer will be deposited. A thickness of about 0.25 to 0.75 micrometer of chromium layer will be deposited. The purpose of undercoating with nickel is to make the surface level, and as nickel is also a corrosion resistant metal, so for that reason, first nickel undercoat will be given, and then a thin layer of chromium will be deposited. Whereas in the case of hard chromium plating, which is usually used for industrial applications, directly on the surface of the substrate, a thick chromium layer will be deposited of 2.5 to 300 micrometer thickness. Now let us see how electroplating of chromium is carried out. So in the electroplating tank, plating bath solution will be there, one anode will be there, cathode will be there, connected through a DC source. I have made a table here. So many different parameters are there which are required for decorative as well as hard chromium plating. The plating bath solution in both the cases contains chromic acid and sulfuric acid. Chromic acid is used to supply the chromium ions required for the deposition, and sulfuric acid is used to maintain the acidic medium, and also it acts as an electrolyte for the movement of the ions. The temperature in the case of decorative and hard chromium plating is about 35 to 45 degrees centigrade and 50 to 65 degrees centigrade respectively. Current density, that is current applied per unit area, is 145 to 430 amperes per square feet and 290 to 580 amperes per square feet. The difference in temperature and current density with respect to decorative and hard chromium plating is due to the fact that in both the cases, different thickness of chromium is to be deposited. In both the cases, the substrate or article will be the cathode. Interestingly, pure chromium is not used as anode here, as we have discussed in the previous slides. Because if pure chromium is used as anode, in the acidic medium, it undergoes passivation, means an oxide layer of chromium will be deposited on the surface of the chromium. Hence, it leads to poor deposition. So, as a result, insoluble anodes like lead tin alloy or lead antimony alloys are used as anode here. So, how actually the process takes place? Chromic acid, which contains chromium as +6 oxidation state in the form of chromium trioxide. These chromium +6 ions, they undergo series of reactions and get converted into chromium +3 ions, which I have shown in the plating bath. These chromium 3+ ions, they move towards the surface of the substrate, wherein they undergo reduction and get deposited as chromium metal on the surface of the substrate. After obtaining a desired thickness, stop the plating process, take out the substrate which has chromium metal on its surface now, and use it for various applications. Here I have shown the different applications of chromium plated substrate. In the case of decorative chromium plating, you can see the silencer pipe or some other parts of the automobile. They are made up of decorative chromium deposit. On the surface of the mild steel, a chromium layer will be deposited. Not only it makes the surface look attractive, but also gives the corrosion resistant capacity. Similarly, one more example I have shown in the case of decorative chromium plating, that is tab. So you can see it looks very attractive as well as gives corrosion resistant surface. In hard chromium plating applications, usually used in the industrial applications, you can see the ball bearings which are which experience a lot of wear and tear in the industries. That is the reason why a thick chromium deposit will be done on the surface of these ball bearings. Not only ball bearings, piston rings, piston rods, etc. All these are having a hard chromium plated on its surface, and various other industrial tools, they are also made up of chromium plating. This is about electroplating of chromium. Thank you.